not literally or figuratively. All right. So first we're gonna review this beautiful document in your, I don't even know what we called this, to be honest, electron emission packet, the very last page, this one right here. So we've been talking a lot about electrons and when they release energy and when energy is put into them or they absorb energy. Right here, this is called a photon. The arrow for the photon is going in to the electron or into the atom. That being said, that means that the electron is gaining energy. And since it is gaining energy, it is moving from the inner levels to the outer levels. It is going out. It is gaining energy. So on your document, you should be drawing an arrow from this circle out. Okay? It is absorbing energy. All right, next up, did anybody see another photon indicated on the document? Yes.
One right there at the bottom left.
Good. And this photon is going outwards, meaning the energy is being released. And so our arrow for this electron should be going which way? In. Inwards. Okay? So, if an electron is releasing energy, it is falling from its excited state, which is right here, back to its ground state. Ground state. Okay, its ground state is its lowest possible energy level. Okay, so make sure you have all of this written in, all of this written in, all of this written in. Okay, if an electron is absorbing energy, it is going from its ground state to its excited state, which is further out. When it's releasing energy, it is falling back to its ground state from its excited state. Energy is released in the form of what? Yes, but in the form of light. Okay? So just a reminder, you shouldn't be on your phone. Yes.
Okay, so my question is, when does energy get leave and come back in? Like, what is the?
That's it. Is this like if you set on fire? What we did in the lab, we set on fire.
Yeah.
That's adding energy to the system. It's releasing it in the form of light.
Okay.
All right, everybody okay with this? Everybody's got this. Moving on. All right. So whiteboard. Now we're gonna transition just a little bit. This will be on your Tuesdays on next Tuesday. So you have Friday and then you have Tuesday. And I decided to give you a study guide. I might regret my decision, but I decided to give you a study guide. So this is also going to be on there. This is about groups and periods on the periodic table. All right, so the first one we're going to talk about is the learning target. The learning target for today is I can, please put your name on this. I can identify and describe the periodic trends using group identities and characteristics. Can you guys see that green? I feel like you can't.
Yeah,
Can you? Okay. All right, once you finish writing that learning target, go ahead and complete that chart quickly. Go ahead and complete the chart. Subatomic particles. Somebody name one subatomic particle.
Neutron.
There you go. Should give you the hint you need. Where's your paper?
I don't have one. so nice. This is my favorite.
You don't need it. All right, everybody ready? Somebody help me fill in this chart. Or do I need to walk around and make sure you've got the chart filled in first? Somebody name a subatomic particle. Proton.
Electron.
All right, what's the location of the proton?
And then nucleus.
In the nucleus. What is the charge of the proton? Good. All right, can y'all see that? Good. All right, next up, we have the next subatomic particle, which is the
Nucleus.
neutron.
Yeah, that's what I meant. My bad.
It's okay. We love the effort.
I'm sorry. No.
Neutron. What's the location of the neutron?
Nucleus.
There we go. Nucleus. And what's the charge of the neutron?
0.
All right. What's the last one?
Electron.
Electron. What's the location?
Electron cloud.
Good. And what's the charge?
Negative.
Good. All right, everybody. So this is something you should know in your soul. Okay. But we've been working a lot with the periodic table, but the real question is, where did it even come from, right? I'm thinking we talked about this briefly, but maybe not. Look over here to my immediate right, my far right. This is what the periodic table used to look like. That's what it used to look like, right here.
Like way back in the day.
CBT. This is the origin picture, okay? I want you to write 2 sentences about what you observe here. Write it, don't speak it. Write it, then we will speak it. Write 2 sentences, complete sentences, subject and verb. Write 2 sentences about this old periodic table. What do you notice?
I have a question. Have you ever been close to this?
Is it about the periodic table?
Yeah. Have you ever been close to like discovering a new element?
No.
But
I
mean-
wasn't in nuclear chemistry.
Oh.
Nuclear chemist. All right, so somebody give me one of their sentences. Yes.
Something I noticed about the old periodic table is that they use Roman numerals at the top. And like they didn't
Technically, they're
number-
Roman numerals on the new one.
Well,
Technically.
never mind.
No, you're not wrong, but technically they are Roman numerals. But that is a good observation because the Roman numerals only go up to 8. So you're not wrong, but technically there are Roman numerals on the old one, the new one. Go ahead. Good. There are missing elements. Can think of another one. All right, Striker, read what you got.
No, I already got another.
I got one.
All right, go ahead, Striker.
There's no atomic numbers.
Missing atomic numbers.
They don't have the name on the bottom of it.
They
the
what?
They don't have like the full name of the element on the bottom.
Okay,
Also, they don't have some of the most common elements.
there you go. So it's missing atomic numbers and it's also missing elements. Okay, what you got?
It's missing some lines to divide them.
Ooh, I like it.
There's gaps.
What'd you say?
There's gaps.
There are gaps. Good. One more. Anything else? Or did that cover it? I pretty much covered it, didn't it? All right, so now let's figure out what happened here. This periodic table was discovered and ordered by a man named Mendeleev. What's his name?
Mandolin, I know him.
Mendeleev. What did one guy say to the next when he was annoying him?
Mandolin.
Manda, leave me alone. Laugh. Harder. Laugh harder. Thank you. And a round of applause. Thank you. Thank you. It was for free, guys. It was for free. I've been working on that one all day
Really?
long. I have. Because, you know, some classes you can't just like, you know what I'm saying? They're like, Miss Stanley, you're weird. You know what I'm saying? I just figured you guys would appreciate it. All right. So Mendeleev arranged the elements using their atomic mass. Yeah, he did. He also arranged them from least to greatest. Now, his old buddy and generations after him, named Moseley, arranged the periodic table according to their atomic number because at this point they had discovered some more of the subatomic particles. All right. Someone try to pronounce this man's name. Starts with a D.
Dobereiner.
Oh, I like it. What did you have?
De Brainer.
De Brainer. I like it.
It's Dauber.
I was about to make a horrible joke. It was so bad. I like De Brainer. I feel like it's not that, but I feel like we're gonna go with it. You know what I'm saying?
Dobereiner.
Yeah, that guy. He
De
used the
Brainer.
law of triads to make a list of elements. It looks a little crazier, but it's still cute. All right, quick review, which you guys should be able to yell these things out aggressively. Are you ready? Okay, most of them. Most of them. I would prefer an aggressive yell. I think non-aggressive yells don't quite communicate. You know what I'm saying?
Yeah.
So I would love full participation. All right, on the periodic table. Hello, princess. Have a good day. What are the vertical rows on the periodic table called? Vertical is this way. What are the vertical rows on the periodic table? Yell it out.
Groups.
Groups that are columns. Good. Groups. But they're called groups, or they're called families. So if you see that used, it's the same thing. Group/families.
Last column, right?
You know, just groups or families. But I do like the effort. Yes, keep it coming. All right, each have the same number of blank electrons.
Valence.
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 Valence electrons are the
Outermost electrons.
So y'all are just gonna leave me hanging.
I
Okay. Gentle. They are the outer. Go ahead and out this.
Outer.
Most electrons. Valence electrons are the outer most electrons. Let me teach. They don't want it. Okay, how many total groups are there on the periodic table? Quick.
18.
Good.
18.
Yes, love it. 18 elements of the same group have similar properties. We're going to prove that in a second.
I can prove it.
Oh, properties. What are horizontals? Period, poo. Period, poo. Is that what they do?
No.
Blue.
Well, I do it. All right, each element in a period have the same number of orbitals. And I'm about to blow you guys' mind about that next week. I'm not going to do it this week.
Thank you.
All right, you're welcome. Thank you for saying thank you. All right, next up, are we good here? Can I move?
No.
Pause.
No.
Wait, that part.
Where is that at?
Okay, so the copier didn't copy the last line.
Wow.
Wow.
Oh.
And I said, copy the line.
You're fired.
And I said, fire. No. All right, here we go. Let's get this next page. Go like the wind bullseye. I don't have time to write you fast, so go fast. Go very fast. Hurry up. And you're going to be missing a lot. It's a poor decision, but we're going fast.
Sorry to make sure you write it down.
Oh,
Don't give them the notes.
I'm just kidding. All right, how many total periods are there? That would be cruel. Close. Very close. Yes. 7. Closest to heaven. Yes. 7. Seventh heaven. Nobody watched it growing up? Whoa. Do you know what it is?
What?
Wait, what?
Whoa. How old are we? Wow, I'm old. Okay. 7. All right. Before we get jazzy with it, there are 3 types of elements. The first one, let's look at our current periodic table. Current periodic. What are the 3 types of elements? Anybody know?
Metal, metalloids, and
Uh-oh, this is the hardest one. What is it?
Metalloids.
Metalloids. Metalloids. metalloids.
said that.
Metalloids are like those fake friends. You know what I'm saying? The fake friends who are like, oh, I love you. And then you're like, oh, you suck behind your back. Don't be that friend. Don't be that person. Okay? So, which one do you think is the majority of the elements on the periodic table?
Metal.
Metals, good.
Metalloids, man.
Metalloids are the fakey people. They tend to behave like non-metals but look like metals. Metalloids right here. Metalloid has two L's. Yeah. Out of me. All right, next up. What are on the right side of the periodic table? These are your non-metals. All right, we're gonna watch a little video. Video. All right, I think you've seen this. I feel like you've seen it, but then again, I've been watching this video all day long. Ready? Your job is when you see an element named, you need to tell me what group it's in. Ready? All right, here we go. Just kidding. Just kidding. False one. It was a joke. It was
Why
a
are you
joke.
standing like that?
It was a joke.
Purple.
Which one is your right here?
Daniel Larson. Daniel.
Well, you know the word.
Yeah. He's gonna get the CEO of Snap. Grace Vanderbilt.
Hey,
He's on
don't
the
forget,
hook.
Cousin Gary's
That's
still
Grace
current right
Vanderbilt.
I'll
now.
go to you first.
Also known as recording.
Whether you've left school or you're still at school, you can appreciate the sheer fun, mayhem that chemistry can be. There's so much to it. Bunsen burners, mixing chemicals. Very nice. Now, you may have been allowed to mix very small amounts of lithium with...
What group is lithium in? Quick. Metal.
Metals.
What group number?
Non-metal.
One. Group number.
One.
Yes.
One.
Oh, no.
water. You may, if with a responsible adult, have mixed H2O.
Sodium.
One.
Are you sure?
Yeah.
What group is it in?
One.
with sodium. And you may, under very strict scientific control, have witnessed potassium mixed
Group.
One.
Blue.
with water. But the odds are, if you have, it will only ever have been on one of those rubbish science videos. There you go, make present. These next two are the dog's nuts of the periodic table. They are, if you like, the king and queen of alkali metals. Mix these babies with water, stand well back, and watch the mayhem. And that's just what we're going to do. Mr. Tickle, bring on the rubidium. Here it is.
Rubidium. My favorite element. What
What
group? What?
Is that it?
Well, it might not look like much, Richard, but it's a highly reactive metal. It's sealed in this glass tube under argon atmosphere conditions, just for safety.
Right, so what's going to happen when you drop that in the water?
Well, imagine, if you will, letting off a hand grenade in a bathtub.
Righto, I'm off. Have that.
Okay, good luck.
Okay, Tickle. Drop the rubidium in the water.
Stand back, everybody, this one's going to be bad.
2 grams of rubidium will only react when our specially designed vial dissolves in the water, which gives John a few crucial seconds to get into our safety zone. Yes! Wow, that is more like it. Only on Brainiac do you get that kind of science. But I believe we can go one better. There is one more alkali metal we can really use.
Yes, Richard, cesium, the emperor of
Cesium. Interesting.
alkali metals, particularly nasty to go off at any time.
And that's it.
Oh, yes.
I like it already. Now, what's that going to do when it hits the water?
Imagine a depth charge in a bathtub.
Fair enough, mate. I'll leave it to you. Good luck.
Thank you.
Okay, John, go for it.
Burning, extreme danger, clear the area.
As our cesium sinks in the water, the rapid generation of hydrogen gas should produce quite an explosion. And it does.
Interesting.
Okay, John, go for it.
Go for it. Go for it. All right, guys, what did you notice? All of those metals were in group what? Awesome. All right, so write 2 details you noticed about the video striker. Reese, what's your question?
Is francium illegal or something?
Francium is incredibly reactive
Yeah.
because
yeah,
there's
I
so
think
much
so.
water in the air too. If you were to have it at all, it would just, you know what I'm saying?
Yeah, I found a pattern. I
Yeah.
found a pattern.
Uh-oh.
Can we
For sure.
Yeah.
Write about it. Give me 2 details on your
Yeah,
paper.
all right.
Can we do a lab with cesium and water?
I'm
Just wait a
getting
little
to
bit.
know
Outside?
because I
Can we
need a
Can we
job.
get all think about it?
We were gonna do potassium, but we didn't have enough. We were gonna blow up the pumpkin in the refrigerator, but
Are you serious?
I'm so
Why
serious.
didn't we do
We make
that?
him play with the lack of something podium powder, but we have to get through this first. All right, here we go. What are your 2 details? What's one thing you noticed?
That all of them have the same reaction, just on different scales.
Group 1,
Yeah.
they all reacted. Say it again.
Weird mannequins.
The mannequins were very strange. You know what I'm saying? The armless part kind of got to me a little bit.
Grace.
You know? I also noticed that, what else? What else did you notice?
What I said.
Okay, was there a trend in how they reacted
Yeah,
though?
They all,
Yes.
it went up in potency. Well, not potency, but reactivity.
Okay, as you,
As you go down the list.
The
okay,
periods,
so
the period.
is it the period?
Yes.
Are you sure?
As the-
Period goes at the end of a sentence. So what would this be? A group.
Yeah, well, no, there's group 1, but like as you go down each period, it gets more reactive. That's what I mean.
Okay, that makes more sense. All right,
Yeah.
so that would, the way you would say that would still be down the group. Because if you,
Yeah.
I see what you're saying. Okay.
Oh, I see what
Like
you're saying.
period
You see what I'm
one.
saying?
Oh, I see.
Yeah,
what you're
yeah.
I know what you're saying, but I'm gonna write it because the trends, the way we describe trends are either across a period or down a group. So we're gonna say as we go down the group, reaction volatility, is that a word?
Yes.
It is now.
It is.
It is now. Volatility increases.
Wait, what? How you gonna make up a word on the spot?
It is a
It
word.
is a
That's
word.
what Shakespeare
Volatile.
did. Volatile. That's how we got most of the words in our English language.
I
Do you understand what that word means?
Yes, violent.
Exactly. All right, group IDs. Let's get these down, and then we're going to color a little bit. Actually, you're easy. You really don't need to be coloring, but it's okay. We'll do
But we're
it.
still kids.
You are. All right, group 1. The name of group 1. Did anybody catch the name of group 1?
Alkali metal.
Good. Alkali
I said that.
metals.
I gave her that.
Alkali metals. Group 2 is called alkaline.
No.
Yes. Alkaline earth metals. They are twisted sisters. They are first cousins. They are awesome best friends. Okay. They only have 1 and 2 valence electrons, meaning they want to give them away because how many do each of them, most of them, want to have to be great?
None.
Close. They want to have 8 to be great. Okay. And so they can give away 1 and 2 valence electrons versus trying to get 7 and 8 electrons because it would be a lot harder.
That's just too much work.
Too much work. So what do you think this blank is going to be? Both groups 1 and 2 want to give good their electrons away. Therefore, they are highly reactive. Highly reactive. Group 13. Group 13 is called the boron family. B-O-R-O-N.
Is it actually called that?
It's up on the board.
Yeah. The boron family. Group 14 is the carbon family. We really won't call them much of this often. Group 15 is going to be the nitrogen family. They also have a really weird name, but I don't call them anything other than the nitrogen family.
What is it?
What is it?
It's like, it starts with a P. It's on your periodic table.
Periodic.
Close, but it's called like the fat.
I think.
On this one. It's on this one.
Oh.
The
Yeah.
Nictogens? Yeah, I don't call it that. I call it the nitrogen family. Exactly. Oxygen family, they have a cool name. They're called the chalogens. But my favorite, the OG, the most amazing, is the halogens. Woo-hoo-hoo. Halogens.
Why are they so amazing?
They are salty.
Ew.
Halogens, they are salty. Does anybody know the compound of salt, table salt? NaCl.
I'm so sorry.
So who's using it?
So which one of those is the halogen? Cl. Knowing that it's Cl, that's what makes table salt a salt because there's a halogen
So
involved.
who's using halogens yesterday?
Yes.
Yeah.
Whoa. Yes. All right. So now that we have done this and talked about this, are there any more questions at the bottom of this, or is that it?
Yeah, there's more.
One more. Group 18. This is called a noble.
Noble gas.
Yes. A noble gas. They don't need nobody. Don't want nobody. They are content without anybody because they have everything they need.
Aw.
All right, so this is the point where you're going to grab a periodic table that looks like this. If you don't have one, you can use the one that has been uploaded to the Squillogies. Grab one from the classroom. You're going to color it and label it according to the slideshow that is linked in the comments below. Oh, yeah, girl, because you know I'm popular. I've got comments.